Hi students, let's look at this question here, which is on vectors taken from the year 2000, paper 2, question 15. All right, relative to the original, the points A, B, C have these position vectors 5, 4, 10, negative 4, 4, negative 2, and negative 5, 9, 5. Find the Cartesian equation of line AB. Okay, this is pretty okay. So I'm going to write down the points of A, B, C. So A, we have 5, 4, 10. Then B, we have negative 4, 4, negative 2. And C, we have minus 5, 9, 5. Right? So line AB, what we just do is essentially we need to find the direction of the line, which is AB. So AB will just be negative 4, 4, negative 2 minus of 5, 4, 10. So we minus 9, 0, negative 12. So I could divide by, this is a directional vector, so we could just simplify it, divided by 3 or maybe negative 3. So it's 3, 0, and 4. So once done, we need line AB. Line AB will just be R equals to any point on the line, which is, I'm just going to use a 5, 4, 10 plus lambda 3, 0, 4, 3, 0, 4. The lambda is a real value. Great. So let's look at the second one, which is find the length of projection of AC on AB. AC on AB. So draw a line. So say this is A. This is B. Or this is the line AB. Not an issue. The direction vector here is 3, 0, 4. Then we need C somewhere. I'm not sure where is it. I'm just going to draw this. Hovering above here is minus 595 here. So we need the length of projection. A will be 5, 4, 10. So this part 2. Okay, line of projection will mean that we need this value here. So if we found, essentially we just project the AC to the line here, right? So just understand that the line, we have AC, and then after which you have a direction vector, which is a parallel to AB, which is this over here. I'm not sure whether it's pointing in the same direction, but it doesn't matter because we want to find the line of projection here, which is we have the angle between these two vectors, which is this direction, and this will be here. Okay, so the length of projection will be the dot product because this is cosine, this is adjacent side, so this is adjacent side. If this is adjacent side, then you know that you need to, this will be related to cosine, trigo ratio. Cosine will relate to dot product, right? So usually what I'll say is just understand that you just take AC dot with the direction vector. Then after which, what we need, let's say this is D. So the length of projection will be the dot product of these two vectors, will be D. And after which, unit vector the direction vector. Okay, do not unit vector the hypo. That's it. So just find AC. AC will just be negative 595 minus of 5, 4, 10. That will be, wait, so this is negative 10, 5, negative 5. That will be 3, 0, 4. Unit vector of the direction vector. Just 3 square plus 0 square plus 4 square. Okay. Then what we do is we just gonna minus 30 plus 0 plus minus 20. So this bottom will be square root 25. The top will be 50. Negative 50. So modulus will be positive. There will be 10 units. That's it. Let's look at part 3. Let's look at part 3. So find the position vector of photo perpendicular of N from C to line AB. Photo perpendicular will be this guy here. This is N. Alright. I think this is a pretty standard question. So what we need to do is essentially, we know that N satisfies the line equation. And we just need to find the lambda which corresponds to the N. Now lambda is actually a housing address. We know that each point on the line would have a different lambda, right? It's a parameter. So we need to find what is this lambda here. All right. So that's the main thing. Find a photo perpendicular. So we just write, copy down the line equation. What we do is for some, so meaning for some lambda, for some particular housing address, I know that ON takes the line equation because it is on the line, it satisfies the line equation, right? Then from now on, in this whole question, entire question here, I just need to treat ON as this line equation here. So I know that this is step number 1. Step number 2 will be we make use of the dot product, which is the 90 degrees here. So we know that d dot cn will give us 0. This would then give us an equation to solve for lambda, which is the thing that we need to find in order to find ON, right? So this case here, D will just be 304. Then after which this will just be ON minus OC. So I think this is not too bad. ON is this entire thing is 304. This is 5 plus 3 lambda. 4, 10 plus 4 lambda. Minus of OC will be negative 595. Negative 595. Alright. So this case will get 304 dot with 3 lambda minus 5. 5 plus 4 lambda. I think it's pretty okay. Then just dot them. 9 lambda plus 0. It's 4, 5 plus 4 lambda equals 0. So for lambda. So from here, lambda will be 20 divided by 25, negative 4/5. Great. So once this is done, we could get our ON. So hence ON, just replace back into the line equation, right? So this point here, 5, 4, 10, minus 4/5, 304. So the position vector of n will be this. So position vector of n. There you go. Got it. Let's look at the subsequent part 4. Part 4 will be the point D lies on Cn produced such that n is the midpoint of CD. Find the position. Okay, so essentially what we need is just a midpoint theorem. Point D is Cn produced such that n is the midpoint of CD. Okay, so just by ratio theorem, I think this is quite a quick fix here. So part 4, what we need is essentially CD. Okay, we have n. I'll just extend the O, doesn't matter where is it at. So n is 13/5, 4 and 34/5. After which we have a C here, which is actually minus 595, right? So position vector of D is here. So what we need to do is just by ratio theorem or midpoint theorem. Okay, we have ON, which is the middle guy, is OC plus OD divided by 2. Just find OD. OD is 2N minus OC. ON is 2, 13/5, 4, 34/5, minus of minus 595. Alright, then just key in calculator. So this is the position vector of D. So hence, okay, so this is it. So if you have any questions or comments, please do let us know and I'll see you in the next question.